Have you ever looked up at the sky and wondered how it could just break? How an entire season's worth of rain can just hammer down in a few minutes, turning a peaceful village into a disaster zone? Well, today we're getting into the pretty terrifying mechanics of cloudbursts and the catastrophic floods they unleash. Just try to picture this for a second. Everything's quiet, the day is just starting. And then, out of nowhere, the ground itself starts to flow like a river. There's no big thunderstorm rolling in, no warning. Just a sudden, violent downpour that literally sweeps everything away. That is the shocking reality of a cloudburst.
So this is the big question, right? This is the mystery we're going to unpack. It feels like it should be impossible. I mean, how on earth does the atmosphere pack that much energy and water into one tiny spot and then just let it all go at once? It's not magic, but it is a very specific and very dangerous chain of events.
Okay, so to really get this, we have to understand what we're dealing with. This is not your average heavy thunderstorm. A much better way to describe it is a vertical assault. And that term, you'll see, is spot on.
Meteorologists have a formal name for this. We're talking about 100 millimeters of rain. That's almost 4 inches, pummeling a small area like the size of a town in just 1 hour. See, a normal storm kind of moves across the land, but a cloudburst, it's like a water tank in the sky just ruptures, dropping its entire load straight down.
But how does that tank in the sky get so full it bursts? Well, the best way to think about it is like a combustion engine. You need a specific mix of ingredients in exactly the right order to get that explosion.
And for a cloudburst, there are 4 key ingredients. First up, you need the fuel, a huge plume of warm, moist air, usually coming in from the sea. Second, you need a trigger, a layer of really cold air way up high that acts like a lid, trapping all that warm air's energy. Third, you need the lift, intense heat rising from the ground. It acts like a piston, forcing that trapped air upward, hard. And finally, when that upward push can't hold the sheer weight of the water anymore, you get the burst. The whole column just collapses.
And this, right here, this is probably the most important thing to understand. We always think of weather as something that just happens to us, coming from above. But with a cloudburst, the ground itself is a huge part of the story. The condition of the land, how hot it is, how dry it is, that's what provides the final spark. The ground is literally holding the match.
Okay, so let's take this engine concept and see how it works in a real-world, extreme example. Over in Pakistan, there are 3 specific factors that combine to turn this whole process into a recurring catastrophe. We're talking about a perfect storm trinity. So the first factor is the ground itself, specifically a landscape that's been stripped of trees and plants. You see, bare, dry dirt soaks up way more heat from the sun than a forest does. This superheats the surface, which creates a massive amount of that lift we talked about, the spark plug for our engine.
And to get a sense of just how serious this is, look at these numbers. Pakistan's forest cover is just 3.7%. That's a tiny fraction of the global average. All that missing vegetation means the ground gets hotter, which generates way more of something called CAPE, convective available potential energy. The easiest way to think of CAPE is as the violence budget for a storm. And in Pakistan, this degraded landscape pretty much doubles that budget right from the start.
Now for the second piece of the trinity, that cold air lid. In this part of the world, a unique weather pattern called a western disturbance drifts over from the Mediterranean. But this isn't just any old cold front. It's how it interacts with the mountains that makes it so incredibly dangerous.
Think of it like this. The Hindu Kush Mountains act like a giant knife. They literally slice off the lower, warmer part of that weather system. But the freezing cold upper layers, they just sail right over the top. So you end up dropping this ice-cold lid of air directly onto the boiling pot of the superheated plains below. This creates an insane temperature difference, which basically winds the spring of the atmosphere as tight as it can possibly go.
And the final piece of the puzzle is the mountains again. This region has some of the steepest terrain on the planet. So when all that supercharged, incredibly unstable air gets slammed up against these massive mountain walls, the whole effect gets multiplied. The steep slope acts like a ramp, forcing a violent, immediate release of every last drop of energy. So what happens when you put all 3 of those things together? You get this. A 9-fold increase in normal rainfall. Let's break it down. The degraded land doubles the storm's energy. The cold trigger from the sliced weather system multiplies that instability by another 1.5. And then the mountains multiply that final release by 3. It all stacks up to a 9x catastrophe.
And a 9x multiplier looks like this in the real world. 300 millimeters of rain in 24 hours. Let me put that another way. That is 6 months worth of rain falling in a single day. There's no landscape, no city, no river that can handle that. The result is just total devastation, which is exactly what we saw in the massive Indus floods back in 2010.
And here's the kicker. These terrible events aren't just random freak accidents. They are the predictable, tragic outcome of a system that is completely out of tune, and worse, it's caught in a vicious cycle that just keeps feeding itself. Let's just walk through this feedback loop. The dry, bare land gets hotter. That heat triggers more violent storms. But because the land is so degraded, the water has nowhere to go. It just runs off in a flash flood, stripping away what little soil is left. And what does that do? It makes the land even drier and even more prone to heating up for the next storm. Each flood makes the next one even worse.
I think this line just sums up the broken relationship perfectly. The land forgets how to rain gently, the sky forgets how to listen. It's a system where the two essential parts, the ground and the atmosphere, they're not in sync anymore. All you get is extremes. Brutal drought, punctuated by moments of absolutely incredible violence.
So is it a hopeless situation? Well, maybe not. If the problem is a system that's out of tune, then the solution has to be about retuning it. And since we now know the ground holds the match, that's where the work has to start, from the ground up.
And this really lays out the two futures available. On one side, you have the path we're on, a hot, bare landscape that creates a huge violence budget, that high cape, which leads to these bursts and floods. But there's another path, a cool, vegetated landscape that generates much lower cape, which encourages gentler rain that can actually soak into the ground and recharge precious aquifers instead of just washing everything away.
So, how do we get from one to the other? Well, it turns out there are two main levers we can pull. First, we have to cool the skin of the earth. That means reintroducing plants, trees, anything to increase soil moisture and bring down that intense ground heat. And second, we need to feed humidity back into the lower atmosphere with those plants and with water bodies. This makes the air a lot less explosive. You're basically detuning that combustion engine, making it run smoother and gentler. And that brings us to one final, really provocative idea. We've been looking at this incredible atmospheric engine as this monster, this generator of disaster. But what if we're just looking at it the wrong way? What if this powerful system, which is so good at pulling moisture from the ocean and carrying it deep inland, what if it could be retuned? What if the very same system that creates these horrifying floods, if we managed it right, actually holds the key to water security for one of the driest places on Earth? That's the challenge, and the incredible opportunity hidden inside the breaking sky.